Welcome everyone to the Tooling U-SME Robotics webinar series. Today we are talking about robotics maintenance and troubleshooting. As many of you know, for over 90 years, Tooling U-SME has promoted the advancement of manufacturing by supporting new technology in industry and the developing of its workforce. One quick housekeeping tip, you will notice on the right of your screen a Q&A box that you can submit any questions you have for our instructor or if you are having any technical issues. We should have time at the end for discussion on our topic, and a recording of today's session will be made available on our website, and we can provide copies of the PDF of the slide deck as well. At this time, I'd like to introduce you to our instructor today, Herb Pierce. Take it away.
Rose, hi everyone. As you know, I've spoken on the last couple of topics, so this is slide 3 or webinar 3 of 4. So first we went over the industrial robotics. We were supposed to do applications, but we ran over on our timing. Last week we did robot safety, and this week we're doing maintenance and troubleshooting. So a lot of this is for the individuals that have robotics already in their system, in their platform, or maybe in their educational institution. And a lot of times you'll find that maintenance is a topic that's very well overlooked. People may talk about it, but they're not doing it. So that's what we're talking about today, is the maintenance and troubleshooting side to help keep the longevity of your robot and your systems working to optimal performance. And then, of course, next week, we're going to go into the applications to finalize this series. So some of you may have heard of, may not have heard of. It's a topic that you're interested in is TPM. It's very talked about in industry. A lot of people try it. They may have not have followed it fully. But if it's something you're interested in, Tooling U does offer those services to help get you back on the road with TPM, but that's something we're going to briefly talk about when it comes to preventing downtime. So we want to prevent untimed downtime through planned maintenance. So it's normal for robotic components to experience wear and tear, but when not properly addressed, this can cause unexpected breakdowns. Of course, those are things that we want to get ahead of. So maybe you may not have a robotic system, or you're planning to put one together. I suggest that when you plan about putting a robot cell together or putting a robot system in, that you clearly predict where the maintenance breakdowns could come from, plan for laying out the cell where maintenance personnel or even yourself can get in there to change these components out, because as we'll go into, the robot itself is going to perform very well. Of course, if it's programmed correctly, will last a very long time. But a lot of the things that I see happening are the support equipment. So conducting routine preventative maintenance allows for users to identify the worn parts and then replace them before failure occurs. Keeping up with maintenance scheduled activities for industrial robotics arms will prevent that unplanned downtime. So of course, TPM, which is also found through the Japanese Institute of Plant Maintenance, there's a lot of great resources there, but Tooling U offers some really good instructional things with that. So when we talk about preventing unplanned downtime, each robot manufacturer is different in recommending the maintenance of whether if it's a daily inspection, it's a weekly cleaning, it's a monthly inspection, quarterly maintenance, or even a yearly downtime. So a lot of the items that come into play when looking at these items for preventive maintenance, and we'll look at this robot specifically on the left-hand side of the screen. I don't think you guys can see my mouse, but it's looking at backing up the program, which is very important. So whether you've just created the program from brand new, the program may have been there for over quite a few years, whatever that may be, these robots are like a computer. So they have the program within them, whether if it's structured text or I don't know if any robots actually do ladder. There might be some, but most of it's like through a special like structured text or C+ or VBE. However, the robots are programmed. That's a whole nother webinar series. If you guys like, we can go into that together. But you want to back that program up. Some robots, especially the Fanics, there's a couple of sets of batteries in them. When it comes to looking at UR, for instance, they have a CMOS battery sitting on their backplane motherboard. So they don't have batteries within the joints. When you look at the FANUC, for instance, no matter if it's a cobot or if it's a traditional robot, they will have batteries in the pedestal for backing up the placement of the encoder to make sure that when power is dropped out and then turned back on, the robot knows explicitly where it's sitting from that point of power off to power on. There's also another battery within the controller. Yes, that's a very good question about what about calibration. We'll go into that in a few minutes, and I'll answer that towards the end. But that also ties into it as well that if that battery dies, and when it comes to a FANUC, you'll see a BZAL alarm, and there's a couple of them that can tie into that. That basically means that the batteries are dead, and robot has no clue where it's at. So yes, you will need to follow the specific calibration procedure. We're not going into that explicitly today, but I will talk about some of the components of that. Let's see here. Okay. Yeah, so that would be towards the end. So that's the batteries. Changing the oil or grease. So when it comes to the cobots, especially when it comes like UR and it comes to FANUC, there isn't really a greasing procedure. However, when it comes to the industrial robots, you will see that there is a greasing procedure. Every joint needs a specific, or each robot talks about a specific type of grease. So I would definitely refer to the manual. If you guys are unfamiliar with it, I would definitely look at getting an integrator in, or the person who may have sold you the robot, getting them involved with the greasing. You definitely want to check the manual for the procedure, what types of grease. You just can't throw grease in there and be like, oh, this is going to work. It's like, no, these seals that are between the joints and the servo are specific greases. If they've gotten contaminated with dust or any kind of product, that's something to look at. ABB actually makes a specific food grade robot that needs specific food grade grease. If any water has gotten into there, there's a lot of specific things that are needing to look at. Even some of the older, larger FANUC robots even have an oil that goes into some of these components. So these are things to look at. Especially what I see a lot of times when it looks for preventing unplanned downtime is the sensors. Whether the EOT was created a month ago, you'll see that sensors that's within the EOT, when it goes to do a pick and place, they may have gotten bumped, they may have gotten dirty. There may be a calibration procedure that you might want to put into place, especially if it's looking at the distance of what the height is. There's a lot of different things. Usually the robot itself, the robot arm, or whether if it's a Delta or even looking at a Scara, the robot itself, if the programming is solid, that robot is going to last quite a bit of time without the specific maintenance. Now, when it comes to changing the batteries on the robot, FANUC will say, okay, change the processor once every 2 years, and then the encoder batteries like once every 15 months. I always tell individuals, change it once a year. It might cost you $20 to change those batteries. But if you wait and the batteries go dead and now the robot loses its position, you're not sure how to calibrate it, either A, you're looking at massive downtime, or B, you're looking to bring a specialist in that you're going to pay, $3,000 to $5,000 to get that done. So by $20 worth of batteries every year is not going to hurt you. When it comes into looking at the sensors, that's a lot what I see breaking down. When they might have gotten bumped, maybe the product may have come in. There's many different scenarios. So a lot of the sensors I'm speaking of, and I don't think I have a close-up photo. Yes, through my slides, I'll jump ahead real quick and we'll go to this slide. So if you're looking at the EOT, for instance, sometimes on top of this vacuum EOT in the left, it's the left-hand picture, second one in, has the orange KUKA robot to it. There are sensors inside to present if those boxes are there. They can sometimes get blocked. That foam that's within the inside of the EOT head, sometimes they may have gotten damaged. So those are things to look at. When it comes to the left EOT, the green one with the Julian head on the UR, there may be vacuum sensors that are in there to be calibrated to see if I did pick up the product. These are things that are well prone to failure that I would highly suggest if you have a maintenance team. It may be on a monthly inspection, or if you're a program and you're programming these things in, I would look at putting some conditional based maintenance with inside of that to say, hey, I've done so many picks and I haven't picked this product up and I've had a failure, maybe it could kick out a work order for somebody to look at it, or it may cause attention for an alarm to tell the operator, hey, this might need to be looked at. So those are things to be well aware of when it comes to the sensors. Checking the motor for backlash. So I would hope that you don't see this. Some of the robots, depending on whether if it's a Scour, FANUC, or ABB, have a tolerance for backlash. So those of you that don't know what backlash is, if I were to go to move the robot arm and it stopped, how much further does it go when it's commanded to stop, or does it have a pushback to it? That's the mechanical gearing within inside the motors for backlash. So those are things you want to check for. It's possibly, if you're seeing that, it's the called excess deviation. So if you're seeing that deviation move more than its tolerance should be, then that's an obvious sign. Either A, the brakes are wearing out, which you should be getting an alarm for that, or B, the servo motor needs to be replaced. So those are things to look at. In some scenarios, whether if it's a very hot glass environment that the robot's running in, it may have a cooling system that may need to be looked at. I know, for instance, KUKA makes a robot that's meant to work in a cooler, so it might be the other way around, where the cabinet itself may need to be, and we'll go into that in the next slide, cabinet itself may need a heater or a cooler, all depending on the environment or atmosphere that robot is sitting in. When I also talk about the robot, I'm talking about the controller that goes with it, which we'll see in the next slide. You also want to look for mechanical wear on the EOD, whether the EOD itself has been rubbing against some sort of object. Even the conveyor system, as you see in this photo here, it's picking from a roller style conveyor. That conveyor is just as important as the robot is to allow it to run at an efficient rate. Those are things that you all want to look at the inspections for. So a part of that, of the maintenance side of this, is the controller itself. So the controller is the brain of the robot. Every robot, I don't care what manufacturer you go with, whether if it's FANUC, ABB, KUKA, they all have a controller. Some are big, some are small. The controller is specific to the robot type because that's giving power to all the servo units. It's the brain of it. It's giving mostly in an industrial environment to the traditional industrial robot, you're going to get 480 to it. There may be some other specialized 220s. Typically, when you go to a cobot, it's going to be single phase 110. But obviously, all your main power comes from there. It has a processor. It has memory. It has the I/O boards. It also has communications that you can go over Ethernet, whether if it's Profibus or DeviceNet. All those are done through this controller for the communications. And of course, the main part is the drive for the servo motors. A lot of times what I see in facilities when I go in there, that the fan that you may see on the top and the exchange of the exit of the cooler on the bottom are completely clogged up. FANUC, for instance, and I even know Yaskawa, that will have an error that pops up telling you I've got a temperature issue. I've even seen Epson robots even do the same thing. So these are things, a part of your maintenance that I highly suggest on a monthly interval that these get cleaned out. You can use compressed air. I probably would not go over 60 PSI to blow these out. You don't need to open the door because these are a closed loop system to clean these out. I know that especially when it comes to the FANUC, it's a closed loop system. So if you were to blow that out from the fan, it blows the dust out. Some of them, you might need more tear down and breakdown for that. But these are things to know that are very important when it comes to the maintenance of these robots. The next item is the robot axis or joints. So for those of you that don't know, robot arms use various joints for movement, including the revolution of the joints from a single axis rotation. Each joint typically is equipped with an actuator, a sensor, and is basically chosen based upon the robot's application. So each one of them, so if you look on the left-hand side at the servo motor, each of them have within that joint, it's a servo motor, obviously, as you can see here. On the back end of that servo motor, almost to the back before the red cap, you have the brake. Sometimes the brakes can be closer to the face of it where you might see the shaft coming out of the motor. You have the encoder, which in the case of this FANUC servo, the encoder is that red cap. In some instances, when you have covers, there's fan motors that are on there to keep the joint cold or cooler. Those may need to be cleaned out to take the covers off. You have bearings and seals that are very important. So when it comes to FANUC or Yaskawa, there are specific places that you need to move the joints of the robot to in order to grease them properly. Those are things to be aware of. The bearings and seals, especially when you start going up to the different joints. And let me move forward to this slide real quick so you guys can see it. So specifically with the FANUC, J1 in the far right-hand corner, J1 is joint for one at the bottom at the base, and you have J2, J3, J4, J5, and then 6 and 7 for the 7th axis sometimes, but joint 6 at the end, which I don't have listed here, is at the very tip between J6 and J5. In some robots, those joints can't be replaced. You have to get that whole piece of that arm. Again, it's specific to the robot, but those are things to look out for. Know that when they get hot, you may see oil and leaking out of them. And that may be something that draws attention to call an expert to look at it. Again, this is just a webinar to kind of bring you guys to the knowledge base of these are the integral parts of your robot and knowledge of how things are. So as you can see, your minor axis is on the right-hand side at the top near J5 and 6. Typically, when you see a 7th axis, it could be at the head. The EOT may have an axis on itself, or at the pedestal, J1 could be attached to like a track, and they may call that a 7th axis. So that's things to be knowledgeable of and know about. Let's see here. So anything else? So of course, axis 1 through axis J1, J2, and J3 are major axis. 4, 5, and 6, of course, your minor axes. That's according to a robot arm. A lot of this today, we're speaking of robot arms, but of course, like I said, the deltas, the scaras, all those apply. So we're going to tie back into preventing downtime maintenance. This is a little comic strip I made a long time ago. The robot says, I'm told you're a robot therapist. And the robot therapist says, yes, tell me your story. I see that you lost home. So things to be aware of, that robots do have a home location. So when we talked before about calibration of the robot, we need to be aware of that a lot of the robots have placards on them. So if you look to the left hand and you look very, very closely at the middle where it talks about the witness marks on when it comes to FANUC or it comes to Yaskawa or it even comes to ABB, these guys have marks that the robot is supposed to be brought to. And then there's a specific calibration procedure that you would follow that's just a manual to say, okay, the robot is in this location and we call this home. And everything revolved around that home location, whether if it's, they call it a quick calibration or a master calibration, these are specific procedures that you need to follow. And then that dictates based upon the joints, whether if it's joint 1 through joint 6, whether these spots are the home location. We talked about the Cartesian coordinate. So we talk about here of the left-hand rule. So it's on a number line where if you look at the base, the and you put your hand like this, your x-axis goes across the plane, your y-axis is forward and backwards. Generally, when you're looking from the back of the robot looking forward, the chord set that comes out the back, that you know you're looking forward to say, okay, my y-axis could be going across the plane, your x-axis can be going forward, but z is always going up and down. So those are the things to be focused on when trying to understand, all right, am I looking at my teach pendant? Where do I understand how to move it? So, of course, it's the FANUC on the left-hand side of that teach pendant. If I'm holding the buttons down, don't worry about the hold button, but if you're looking at your X, your Y, and your Z, you're moving J1, 2, and 3 in a world coordinate. It's moving that entire robot in the world. I didn't go quite into frames and things like that, but the robots have different coordination, whether you're doing a joint move or whether you're doing a world move. So when I talk about world, that will be moving the robot around the entire world cage. It's easily part to think about it of the robot. If I was talking about a coordinate move of doing a joint, that's moving the specific joint, positive or negative, left or right. So those are the specific joints that we're looking at. And we'll go J1. If I'm moving J1 positive, well, the robot will rotate this way. or if I go J negative, the robot will rotate this way. So those are things to understand about the left-hand rule. So if you put your hand out, your Y is going to go across the front plane. I think I might have said that backwards the first time I said it. But your Y is going to go across the front plane. Your X is going to go across forward to backwards. And Z is always up and down. So those are things to focus on. There's plenty of YouTube videos that could help you out with this if you don't quite remember what I've mentioned before. So that's how you focus on that. Now, depending on what coordination you're in, whoever set up your robot, they can be switched based upon whether you're looking at the frame. Now, when I mentioned the frame of the robot, these robots can have multiple frames. And when I mention the word frame, just so you guys don't get confused, in this scenario, I have a pick station. We're going to look at the right-hand photo, and I have a pick station. So we see those little rollers that are in there, and then we go to the chain conveyor. So on the left-hand side, I'll say I have a pick station there. On the right-hand side, I may have a pick station there. So those will be called frames. And say going down the middle of that, which was not pictured here, could be a conveyor. That would be another frame. So at this point, I have 3 frames that could be taught. So typically within that frame, I can then convert the XY coordinate, whether if it's going to be towards the fence or away from the fence, or towards a robot or away from the robot. Those are all things that are for a much deeper topic, but those are things to be knowledgeable of, and that's according to the frame. We're talking about according to world when you're doing the right-hand rule, that is specific to the entire envelope of the robot reach. So those are things to understand. I think that's all I pretty much asked specifically about this one. And then next slide, we talked a lot about where do most failures happen. So as I said before, is the support equipment. You have the robot fence. So of course that could be the fence is opened and closed thousands of times, hundreds of thousands of times through the lifespan of the robot. Of course, you're going to have wear items such as the safety switch, the interlock connections, cord sets that may be unplugged and plugged back in. Of course, we talked about earlier on the left-hand slide that the EOTs, you're going to have failures there, especially if somebody didn't program it right, and the EOT may be crashing into support equipment, such as the conveyor, or something may have drifted and it's going down. I've seen times where the conveyor itself, so the robots have what's called a tracking method. And that's if the product is moving down the plane of the conveyor and the robot has to follow it and then pick it. So I've seen cases where the conveyor has stretched and the robot may be delayed in its picking. So these are all the different things that happen. If the robot is programmed with efficient moves, such as it goes to A cell and D cell properly, those joints are going to last a very, very long time. But if a robot is programmed where it's doing hard curves, it's doing joint stops and start, and it kind of looks like we'd say like somebody doing a robot dance, that's going to wear a robot out very quickly. The joints are going to wear out, the servo motors are going to wear out, and that robot is not going to last a long time. I have seen robots run in excess of 25 to 30 years without a problem because they've been properly greased, they've been properly maintained. Things that I see wear out are the accessory equipment, the photo eyes, and things of those natures. So those are things to look at. So again, your safety fence, the EOTs, the conveyors, whatever fixtures may be around it, those are things to look at. Maybe if you're also setting up a robot, I have seen this scenario before, make sure that you guys are using liquid anchors when you're affixing the robot to the floor. There should be within the guide of the robot how to appropriately affix it to the floor. And I've also seen when you do mount them to the floor, the threads that are popping up, do people a favor and cut the threads probably within maybe a half an inch of the nut so that you don't have issues of people hurting themselves when they're walking around the pedestal. These are all just like general maintenance items that should be looked at. And then, of course, the controller and the support cabinet may need compressed air to blow the dust out. I highly recommend that when you are using control cabinets that there's air conditioners put on there because those frequency drives do produce a lot of heat. So those are just some minor things that can be done to avoid a major breakdown or downtime. All right, so that's all I have on this slide. And the next one is to go into questions. So, all right, so I believe we talked about the calibration. So yes, when it comes to calibration, you will have to bring those joints to the witness marks of 0. And there are times, depending on the applications, I have not seen it myself, but I have heard to where if the equipment was made and I could not get the robot to all the witness marks, I know specifically with FANUC, there is a special procedure that you can do to get around that. So that one's to answer that question of calibration. Let's see here, the next one is, okay, it's all about calibration. I'm not sure where to turn. We have a, see here, brake press. I can't get a function. All right, so we can talk about that later, Jason. All right, who else? Any other questions that we have? We got 4 minutes left. Anyone? Hopefully I answered all the questions. We got 4 minutes, guys, for questions if anybody has any. All right. Again, while we're waiting for some more questions to comment, okay. What is the difference between home and start? All right, so that's a very good question. So the home position is, you could refer to it as a 0 position. So we talked about lining up all the witness marks. So if we go back to here, that home position could be the 0 position. The home position also could be, say we're looking at this palletizing system here. I'll go back to this one. And its start position, we see the EOTs. It's kind of that square looking thing in the middle. If that robot is sitting there and it's waiting for either side of that conveyor, we have conveyor to the left, conveyor to the right, whichever one is waiting to get palletized. Your home position could be in the middle, or it could be at a pounce position, or maybe we're not using the left side, but we're using the right side. Your start position could be hovering over the conveyor to whatever side you decided you're going to use that day. That'll be your start position, but your home position could be in the center to say, okay, what do you want me to do next? So that's the difference between start, home, and yes, there is a 0 position. You could define all those within your program. So hopefully that answered your question. All right, the next one is, should PMs be done by the OEM or integrators? So the answer is yes. When it comes to the OEM, so original equipment manufacturer, if we'll say FANUC, for instance. So FANUC is the OEM, but I also consider, if you were to use, like, say, Bob Jones robot service that makes the robot sell itself, I also consider that the OEM. So the answer is yes, that both FANUC has a service company. Typically, what I would suggest is the person that made the robot, they do the service, because if you were to call FANUC or you were to call ABB, they will only work on the robot itself. They will not touch the EOs. They will not touch any of the support equipment. They only touch the robot. So my suggestion is either A, you find an integrator that will service the robot itself, because then they can also look at the accessory equipment, or the OEM, if they're still around and they do service. Some actually don't. They just make the robot, and you have to find an integrator that will do services of that nature. They will work on the robot and the surrounding equipment, because know that in a system like this that we see here in front of us, there's the robot that has the controller, and then there's also a PLC that's attached to run the accessory equipment. So that's why it's better to get an integrator, or the guy that made the robot cell, which I would call the OEM, will service all of that. And that's really what we should look for. All right, the next one is there any reference to websites that you can recommend that concentrate on on cobots? You know what? One website, for instance, oh yeah, and that's one thing I forgot to go over. Okay, I'm right at the time limit. I know I had it referenced in one of these slides. There are a couple websites, and I'll get back to you on that I even go to sometimes if I've seen something I haven't seen before when I'm troubleshooting these to get to it. But one thing I did want to mention on the slide, the right-hand picture, this is a picture of a FANUC. If you look at the top row and you look where it says pick place to line T2, if you're watching the robot code, it'll tell you where it's at, just so you can understand. Yeah, so there you go, Clint. UR does have specific training. It goes over the trainings itself, but there are other websites to go to, and I thought I might have had it listed. Here it is, DIY Robotics. What I went to here, courtesy of right hand rule, they're a good place I see a lot of people go when they're looking through blog on how to fix something. So that's something, if you feel as though you're comfortable getting in the code, I would recommend if you're going in to make any edits that you feel comfortable doing that, because if you go in and change a line and you're not understanding where you're going, bad things can happen. So I would definitely make sure that you're comfortable with that. If there's anybody else that has any other questions, of course, they can get a hold of Tooling U. They can reach out to me. I can definitely even come on site through Tooling U to help your team out with anything you might be looking to do. As far as setting up a system or you can't figure out a system, we can definitely be of service. I don't have anything else to add to that. If Rose or Angela, if you're still there, want to close us out?
Yep. Thank you, everyone, for attending.
All right. Thanks, everyone. Have a great day.